Entropy and its physical significance. Today, the topic is entropy and its physical significance. It has come in the past paper many times. Whenever we talk about the chemistry, we are concerned about the state of equilibrium, the tendency of a system to move in the direction of equilibrium. Number one is our tendency, to find out the tendency of a chemical reaction, and the number two is that to find out whether the equilibrium stage has occurred or not. Means that a chemical reaction is always concerned about the equilibrium stage. So there are the factors that are not reliable to find out the equilibrium stage of a chemical reaction. For example, the internal energy factor, enthalpy factors. There is a factor that is highly reliable to find out the equilibrium stage of a chemical reaction. That factor is the entropy. That factor is the entropy. So it means that when we talk about the equation that we have derived in the Carnot cycle, it is Q1 over Q2 is equal to T1 over T2. You know, Q1 is representing the heat coming out of the hot body, high temperature reservoir, mean T1, and Q2 is the heat rejected from the system and going towards the cold body. As the Q2 is the heat emitting out, remove, it is represented by the negative value, and the Q1 is added to the system, so it is being simply added as positive. So means that only once negative will be added in the equation to determine the further derivation. By putting the negative value, equation become in this form. By taking the T1 on the right side and by taking the Q2 on the left side, equation changed into this form. By taking this negative factor towards the right side, equation changed its form in this way. And when we add up these two factors together, or these two separately taken values or fractions, these formulas appear in this form. What is sigma? Sigma is showing the sum up. Simply, when we are saying that T1 plus T2, T3, we can also write sigma T, which means the add up of the T1, T2, T3. Here, the same rule apply where we are saying Q1 over T1 plus Q2 over T2, it becomes sigma Q over T is equal to 0. Q over T mean heat divided by temperature is showing or is representing or is equal to the entropy. So when we write here the sum up integration delta Q over T is equal to sum of integration delta S. We are saying here that sigma Q over T is equal to S. Simply we can say that differential of entropy is equal to differential heat divided by time. So the new variable, this one is called the entropy. Entropy is also a state function. What do you understand by the meaning of the state function? Let me help you to find it out. So we are meaning here to be said the word of state function means that the function that is independent of the path. The function that is not depending upon the distance covered. It's all about other factors. So in the process of cyclic chemical reaction, the above equation, the entropy change become 0. So since the derivation is all about the reversible process in the Carnot cycle, so it means that it's better to use the del Q reversible rather than simple del Q. So it's better to use the reversible symbol along with the heat symbol. So the equation finally become ds delta or del Q reversible divided by T. As we are talking about the entropy, where we have derived the formula for the entropy, that is the heat divided by the time. So entropy is about the heat is about the change variable, and it's in the reversible process, so it is not the exactly differentiate value, or it is not exact differential. So exact differential in the above equation is the entropy. So entropy can be explained or further written in this form where we are saying delta S is equal to S2 minus S1, and it means that the range applicable here is range is from 1 to 2. So equation, though, what's the meaning of the literal meaning of the entropy? It's derived from the Greek word "en," which mean in, and "trop" mean change, means that the change inside or transformation. So the proper definition of entropy of a system can be said that it is a state function, number one thing, because it does not depend upon the path, and its change is equal to the ratio. If we are talking about the change, number one thing, entropy is a change, and it's not a state, it is a state function. It is not, it does not depend upon the path, and its change, if we talk about its change, so its change is equal to the ratio of the heat change, mean the ratio of the heat change to the temperature at which heat change occurs. It's reversible, because we are talking about the reversible or cyclic or Carnot cycle process. So we will say that the change in the entropy is actually the change in the ratio of the heat with respect to the temperature. It is an extensive property along with the state function as well. Extensive property is such a property that depend upon the composition or the size of the system, like the volume and internal energy factors does. These the volume factor and the internal energy factor also depend upon the composition. So these two factors also depend upon, and these two factors are considered to be extensive properties, similarly to the entropy, because entropy is also depending upon the size of the system. The unit used for the entropy is joule per Kelvin per mole. How it is obtained? Temperature is giving the Kelvin, because it is in the denominator form, it becomes